Damn it, and OBS crashed. Let's hope we can resume here. Was this 0 drop frames? Are we hopefully reconnecting this? But anyway, this is You Are Live. How long have we been offline? I hope I noticed quickly enough. So much to OBS crashing. Why does it sometimes crash and some days not? And we have now probably a new stream. Damn it, you've seen the other day we intentionally did not want it. So you will not believe, really a pity. The other day we wanted to start a new stream and it didn't start a new stream, and today OBS disappeared. I quickly restarted it and we apparently have a new live stream. You will not believe what I read there on this signature. This is really depressive. Unbelievable. You will not believe what Efficeon this is. This makes me really want to go hunt for a code morphing software. But I think I will stop polishing this here now. Computer's glad I'm not the only one. Somehow, why is this so smeary now? Okay, maybe we just leave this there like it is and hope. Because so what is there that this is so smeary? This is acetone is otherwise doing quite a trick. So you will not believe. I hope we can we macro focus enough and not shake the camera. Is this visible on camera? This is in Transmeta. By the way, don't forget to share, like and subscribe and recommend our stream because we need more AdSense revenue. I need really a macro lens. Can I read this? Sorry for shaking this here. Trying to, oh damn it, this is, I also maybe need a window manager that is X-render aware to have here a better experience. So just need to resize here my window that I can better see what is on the camera. So actually I think this could be visible if you watch in, actually wait a second, does it focus better like that maybe? So I hope it is visible, at least with my eyes through my glasses I can read, at least when I'm not busy holding it in the camera. That this is an 8820, this is the very last generation Transmeta, just at Hewlett-Packard, as I already speculated. I think like this it should be seeable, right? And by the way, this, come on, how is the best? But I think you could already read this, right? Maybe leave me in the comments below. And again, we need a macro lens. So this is, let me just verify here. With my eyes, TM Transmeta 8820. I'm pretty sure that should be Minites, or is this some manufacturing code? Let's see. No, this pretty much should be the CPU model 8820. Or is this a date code? Probably not right now, I think. No, the date code there's probably 0514, I guess, so probably in 2005. Does this match? Maybe also not film our floor here. And yes, I know there is no link code in it. So, just as I already expected, this is like it should be latest Transmeta. Maybe we Google this desktop and camera and anything top secret there, no. But I probably don't even need to Google this. So we have the very latest silicon, and by the way, the internet suggests, all the press release, the 8800 was just a die shrink structure. It was manufactured instead of, let's look this up, TM8800. And Hewlett Packard, just for their logistics and laziness, and they just didn't bother updating the code morphing software. So this SSE3 probably was just code morphing by itself. And by the way, I think the German article yesterday we saw had more details, because here is not much. So we have the very latest silicon, just not the latest code morphing software. This is really sad, and this is what I meant with generations. So they had here, of course, multiple generations also inside the Crusoe family. So 8820 is the very last that should have SSE3, and as I expected already, because this is a die shrink from structural manufacturing process of previously 130 nanometer at TSMC to 90 nanometer at Fujitsu. And as I already expected, this is just a die shrink. They probably didn't have so much money and employees anymore. And this SSE3 is a pure code morphing transformation, as this was already very large instruction word with multiple single instruction, multiple data things. And yeah, Hewlett Packard just didn't update the code morphing software. This makes me really sad and want to hack me more on this. Maybe leave me in the comments below what you think about this. Of course, completely hard to find this code morphing software. I googled around there a little bit, didn't find much references anywhere. As I said, there was one update for Crusoe for a tablet, and this is what people used to, or people, at least one. You find an article there somewhere, also reposted somewhere, maybe Ars Technica or something, that maybe this triggered Transmeta not to be very eager to unnecessarily release code morphing. And again, articles suggest this was with code signed with two crypto keys. So you have one crypto key from Transmeta and the second public key for the vendor, like in this case Hewlett Packard, but could also be Sony for their picture books and such. And where is no? So this is thermal compound, and this is why you cannot just update the code morphing software. Maybe in one of these EEPROMs there is code morphing. So this is P558H1. Actually, this is in 2B1. Maybe I should actually focus this more. And yeah, really wants me to search the internet in dark corners and find code morphing software. As I said, if someone has a source code, this would be so amazing to hack stuff in there. Virtualization extension, maybe even 64-bit just for the fun of it, even if it's not as performing, but just for the pure sake of hackery. And there you see what you can do if you have the source. It would really be so nice of vendors, but somehow, of course, companies purchased it for the patents and such and technology. And yeah, but nonetheless would be nice. So here's the designation on this. Flash chips there is B12G, maybe second generation, I don't know, 6046 1.02 and then _1 and 2. Maybe one is the BIOS, maybe the other is a code morphing software, because the BIOS is already x86 and the code morphing software, I think as far as I understood from articles and such, I will, by the way, not use this nozzle thing here because I don't want to have this expensive compound stuck inside there. I think I will just make there a small drop and rely on just, can we, oh, was there, wait a second, was there something, was this, this was a closing thing, very clever from us. Oh, wait a second, oh yeah, okay, this was, yeah, I don't do this every day, but with this recurring YouTube theme, we will do this more often. And this is also what you get when vendors don't care. Then, like with all those Apple defects we posted the other day, and we have the same with this Oko01 that I made a video about. By the way, I really wonder that this is moving so hard. This is really a little bit, not that you have your one drop and okay, now it moves. Let's see here a little. Really wonder why this moves so. But as you know, not too much, but you probably also have seen from other YouTubers that it doesn't matter too much. Other huge YouTube channels have done testing and overdid this. It was actually not as bad as people always said it would be, but anyway, don't need to waste here so much of this. It will naturally spread anyway with the pressure from the heatsink. So just like this, the rest will or should. Okay, here we don't see so much anymore, otherwise I would have made a small drop, just a little bit here of this residual. Should this looks more or less like this should be enough. And the point with this nozzle is, otherwise if I use this stupid nozzle, then I have all this stuff there in this nozzle and I don't want to waste anything of this precious stuff here. And yeah, I would really wish that if companies go out of business, that they release some of the stuff that enthusiasts and fans can continue to use it. So this was like this now. So we need to bend this a little bit over there and zoom in there a little bit. I hope you enjoy my efforts to keep the camera focused and such. So just bending this over there. This is even not really on camera. So we have the very latest silicon, the very latest power efficient, and just no SSE3 because not in the code morphing software. So this is in there again. And then this is so much pressure. You always want to be careful that you do not damage the silicon somehow. Why does this fit so shitty? Is this just the pressure from... Somehow this is irritating. By the way, why is the heatsink bent? I certainly didn't bend it, just realized now that the last fins there are bent. Somehow this, I don't like how this fits there. This does not really, but okay, the die is actually super tiny. Maybe we shortly take a look. Okay, this already spreads there on the heatsink. So exactly what you not want, to rub this stuff all over the place, but somehow not really reassuring. I hope that, because the danger is with this kind of thing that you break corners of the die, and then with this potentially some transistors and logic gates off of your precious CPU. Okay, so we have this in again. I hope this fits somehow, hopefully, maybe. We probably should see. So as I said in the very beginning, a pity that we are here a little bit short on production time with the amount of subscribers and viewers scratches a little bit, but this probably could be okay with aluminum scratching on the die. Let's just reassemble it and hope for the best. And yeah, really sad, really disappointing from Hewlett Packard. This is exactly what we had on the Oko with the Crusoe Efficeon. I can hold it in the camera again. That is this precious little machine that you might want to take a look on. Guinness World Record smallest PC from 2005, and there we had a 3D chip where this, I mentioned this Silicon Motion Links 3D, only had 3D support for Windows 95, and obviously they shipped it with Windows XP Tablet Edition, so all the customers never had 3D acceleration. And this is the attention of details of PC vendors. And where's our plectrum? Did I put this back already? Or will we find out? Oh, here we used this for scratching. Yeah. And yeah, attention to detail not. And I'm not really disappointed that I indeed have the very, very, very latest processor from Transmeta, just not the very latest code morphing. I have not missed it, but as so often, if you don't miss it, if you don't know, you don't miss it. And if someone tells you in the YouTube comments, hey, you have SSE3, and you wonder, wait a second, do I have SSE3? Do not really remember this. And then you find out, damn, you don't have it. And then you miss it. Also, however, a nice move that this NVRAM battery is socketed there, not like in other machines. And yeah, so without this PCI extension thing, obviously, here is a metal case just going over there. And with that, we plug in here our Digi32 that we would want for some digital audio goodness, as seen earlier. And by the way, maybe I should reload here. Are there any comments in the audience? I hope you enjoy this quick interim updates. And there is no on the floor, of course. Where else would we store it professionally? And yeah, really sad that OBS crashed in the middle of this live stream. Again, better speaker, whopping 2-watt speaker. Really wonder, maybe on airports or something where they use this thin clients, they wanted super loud notification. Maybe it was in some international tender that the specification was needs to be super loud speaker, because as I said, completely annoying, especially if it beeps like on the terminal. And yeah, I hope you learned something from all the discussions, also code morphing. And this, maybe I make a dedicated video. I read all these papers when this Crusoe was in the works around 2000. I read these papers in bus to school and such. It was really interesting to read such kind of processor design. And they used really many clever tricks in the software and with hardware features to make this as performant as it was. You have seen the CPU there, really small, much smaller than the ATI mobile Radeon in there, and certainly quite low energy for the performance. Of course not on par as Intel Pentium whatever, but quite good for this kind of code morphing setup, I think. And knowing that what kind of CPU we have, maybe for whatever time in the future we have the opportunity to tinker around with. Maybe someone someday sends me some code morphing bits, or we really tinker around there. We could also, the problem is that often this kind of stuff is expensive on eBay, otherwise we could theoretically get another machine, completely different laptops, there were a few, and try to just read the code morphing software from the EEPROM and install it in here. Not sure if that would easily work. As I said, it should be digitally signed, but who knows. But that is something for another day and probably even year, because we have other more important things to do first. But just to inspire you what kind of stuff you could hack on. Let's hope it still works. The only thing also is a little bit fragile. I always have the feeling this will break soon. Is here this small plastic stuff. Somehow not the most reliant, you would think. For the thin client, for wherever they used thin clients, they would make something more reliable. This somehow, I have the feeling this, you push it a little bit and it breaks off, but whatever. And let's hope it still works. There might be a BIOS update, but it's not so clear written on the Hewlett-Packard page, and I'm also not convinced that, neither convinced nor enthusiastic that the BIOS contains the code morphing software, because it probably only updates the x86 portion, but because as I said, the BIOS is already executing as x86, and so also intentionally not to, because obviously the CPU is code morphing x86, so that is why it makes sense that people can reuse their knowledge and do not need to bother with code morphing. Certainly the BIOS has to be x86 for DOS and Windows anyway. So let's hope for the best. So I think we had here flickering. That should mean here the thing comes still up top and escape or something. Actually here it says actually TM8600. This is funny. How can actually, oh wait a second, no, this earlier, right, this earlier was already saying, so the problem is we have an Apple keyboard without delete key, so it still works. I could, what we could do for performance test, I could maybe re-emerge some package from source and benchmark if the performance with the thermal Grizzly F10 to enter setup, entering setup, hey, F10 works with this bloody Apple keyboard. So what kind of information do we get here? TM8600. Actually here they also write code morphing software just as I've shown you. So this is code morphing software just like yesterday in my own x86 info. And by the way, you see the memory size is unsupported. It overruns here this 3-digit thing to a colon. So they have their probably 0 plus something very cheap coding of number to something that this overruns. Certainly not a printf or something really cheap custom formatting here. And at least I think so. So system ROM is 786 R2 version 1.02 and code morphing just what we have seen yesterday, 604. And yeah, this is apparently not the latest. And as you have seen, I told you yesterday, as far as I know, this this TM stuff there is just statically included in the code morphing software, and this is why neither the BIOS nor our own x86 info stuff has knowledge that this is a TM8820. And yeah, need to check with the BIOS update. I have the feeling this could already be. Let's maybe check here live on YouTube, or first check maybe what else we can see here. I'm already happy that this still works. So the battery is not yet dead, it's still showing their battery info. And yeah, just the usual BIOS stuff. Thanks. Really thankful that this still works. Escape to quit, quit without saving, yes. Actually, maybe I should have. Thanks for checking. Really nice to have people in the audience who check here the BIOS versions on the fly. So yeah, anyway, I don't think that the code morphing is in the BIOS. That is not what other stuff on the internet suggests, which, so we have 316 and okay, this is newer already. Yeah, I guess we make another live stream on the main channel with other stuff. I hope you found this interesting and learned something. And the BIOS does not seem to contain the code morphing software. Yeah, this is what I said. This is not what my experience of previous Googling suggested. And it should be in the EEPROM. And I wonder if you can just swap the EEPROM over, or like read the EEPROM and Okay, somehow we have here this not perfect, super old T2 or something. And even if you swap over the BIOS, not sure if this works, because I wonder where the crypto keys are in there, because the internet suggests that you can't just swap it with another. And by the way, because as I said, the internet suggests, or documents from Transmeta, you never know if this is true or not, but you find there that there should be 2 public keys, one signed by Transmeta, one signed by the vendor like Hewlett-Packard, because apparently the code morphing software also includes thermal details like Sony picture books, heads and other parameters for less cooling and more compact form factor. Yesterday I grabbed here for CMS. In the meantime, I found that it is code morphing here actually. So here we have it. What I didn't find yesterday because it wasn't CMS, it was code morphing software, and this kind of strings come out there from the with CPU ID instruction from the Transmeta extensions, and they come out there as strings just like the 6 other CPU ID info strings like AMD, Phenom, Ryzen, Intel, whatever you name it. So this is hard-coded in the CMS code morphing software build and just statically returned there as strings. So 604-1-62, no idea why these are slightly different encoded there, but whatever. And yeah, you see they built this there at some time in the night in 2004, 7:23, and yeah, we could actually theoretically test build here something, but I guess we better do something more interesting, what kind of performance we get with this new thermal compound there. And because we have the time encoded there in var ADM packages, so whatever we build locally, like yesterday for example, we had this failed x86 info, and this built here from 39 to 40, not such long time. Maybe for a quick test we could actually redo this, although this of course will error out, but just for a quick test, see what we get. And yeah, I can't, maybe I should tweet, maybe some of this former engineers still has code morphing source code lying around at home. That would be really amazing, but chances are probably slim. But you'd always wonder what kind of sources manifest on the internet. Would be really amazing if we would have this. And yeah, otherwise some point in the future maybe. And also, by the way, if you have a Transmeta Efficeon and you have a later code morphing software, it would be really amazing if you could read it out for me with some EEPROM programmer things. So we got here, how many seconds this built from 5 to, of course, super non-scientific. This built 33 seconds. And somehow yesterday it was slower, so maybe we are completely super lucky, unless, how long have we yesterday been running to pre-warm this? But maybe, at least it is not worse. Of course, super non-scientific. We could, in the loop, build this now many times to see if this yesterday just was more pre-warmed. How long did we boot yesterday? Not so long really. So because this was over 40 seconds for whatever reason until the fail. So it is significantly faster today. Not sure if this is. Actually, we could theoretically, I benchmarked this probably at some time ago, last year, for this huge benchmark shootout. Do we have this open bench? I don't have it laying around, or in home Rene source open bench. Hey, here we have it. I could very theoretically, maybe if we are completely, totally lucky. Yeah, we have here results lying around, so we could actually rerun this open bench just for the fun of it. This would, of course, expose any long-term thermal throttling. So even a second build, 29 seconds straight. So not too bad. Maybe this thermal compound reapplying really helped a little bit if we are completely super totally amazingly lucky. But again, share, like and subscribe to support me here for long-term more scientific methods of actually running OpenSSL or something long-term. By the way, for the outro we could actually run here OpenSSL, what was it, speed, or speed. We could run this here for a very long time and preheat this here and see if we get here some kind of thermal behavior. But yeah, like with the MacBook where I thermal compound reapplied this on my main machine, I have not done scientific benchmarks. Of course, it would always be the right thing to do. Let's cancel and rerun and see. We got here 2000. Actually, this is quite, actually now it's slightly faster for some strange reason. And not yet thermal throttling, so it's not as bad as an Apple MacBook. Apparently, even this is slightly faster, so second run, slightly faster, so not, okay, not, this is here in the margin of error. This is similar, so here, not yet getting too much thermal throttling. Hello, can we, no, we get this 2000. How much do we get now? 2500, yeah, still stable. So it's not thermal throttling as much as low quality Apple products, allegedly. So here, not too bad. Yeah, we learned something. We have the latest Transmeta Efficeon TM8820 in there, just not the latest code morphing. This is why the code morphing is not giving us SSE3. This also probably means that the code morphing is compatible. Hewlett-Packard, as we all know, Hewlett-Packard not the most outstanding company in the consumer and server space there, in my opinion anyway. If you have another opinion, maybe leave it in the comments below. And as little as they usually care, they did not care to update the code morphing software. And it's apparently maybe as compatible as sharing between TM86,000 and 88,000. And maybe another year or decade we continue tinkering if this survives with scratching and isopropanol alcohol and nail polish remover there, and nothing is in the long term being destroyed there by our chemical residues there. And maybe here after running quite a time, let's restart it and see. We had here MD2, of course now it's scrolling away, 259, but it's still stable amazingly. So actually the thermal performance of this die shrink thing is not too bad. As you see, you can still work comfortably. I think as per my previous huge vintage benchmark things, I think the performance was certainly much higher than SSG iOctane, and maybe even in the ballpark of whatever else this was, 1.2 gigahertz cube or something. Need to look this up again. But yeah, what did we get there? We got MD4, just scrolled away, 78, 134, 134, 136, yeah, one. So yeah, not too bad. And maybe I live stream another episode on the main channel with some latest developments. This was just getting ready here, pre-training, saturating the TG3 Ethernet. Of course today only OBS crashed because somehow each live stream something has to happen and crash and whatnot. And I hope to see you soon for all the other tinkering live streams, reviews and programming.